Hey, welcome back, Honors Theochem. So today, now we've talked about the different types of radiation, alpha, beta, gamma. Today, we're going to be looking about how we actually go about starting to draw or write these types of changes. It's going to be kind of similar to what you've seen before for our chemical reactions. We start with some stuff and we make some new stuff. But we do need to think about how we would show that. So by definition, a nuclear reaction is any reaction that affects the nucleus of an atom. What that does mean is that on both sides of your change, the total atomic numbers, number of protons, and the total mass has to be equal for both sides of our equation on our reaction. We do give this a name. Any reaction or any change that changes the identity of the nucleus, because we've changed the number of protons, is said to be called transmutation. We've transmuted it from one thing to another. It's changed its chemical compound or chemical makeup. We show these using what we call decay series, and there's a couple of terms there we need to talk about. If at any point you need to pause it, feel free to pause it, get your notes, and then we'll keep on keeping on. So we call these a decay series, and we start to kind of show these changes and kind of write these out. And in order to write a decay series, we need a couple of terms. Decay series is a series of radioactive nuclides. Remember, nuclides is an atom, fancy name for an atom. And these can be produced by continual or successive radioactive decay. So if you got something really, really big and it breaks down a little bit, well, it still might be unstable. So it might break down a little bit more. It might break down a little bit more. And it will keep breaking down until we finally get to a stable nuclide, a stable atom. And this varies depending on how big the atom is and how it's breaking down, and there's different ways this can be done. But we call this a decay series where it just keeps breaking down and breaking down and breaking down until we finally get to a stable final atom. Now, there are a couple terms here that we should be familiar with. We've got our parent nuclide. This is the heaviest one. This is the one you're starting with, right? Parent comes first. It's the heaviest. And then it continues to break down. Every time it breaks down, it makes a new atom or a new nuclide. We call it the daughter nuclide. That's the new nuclide that's been produced. So for example, going to hide for just a second here. So for example, we want to look at an example. So I don't know, uranium-235, sure. U-235. If we look on the periodic table at uranium, uranium is number 92. 92. This is our original parent nuclide. We could have that decay or split down. It's really honking big. 235 nucleons in the center. We're going to start just with an alpha particle. I don't know if this is how it decays. If this is its preferred series. We're just practicing here. And so let's go ahead and give off an alpha particle. Now, remember from yesterday, we said an alpha particle is a helium nucleus, He. That's 4 nucleons, 2 protons, 2 neutrons. Here's our alpha particle. So essentially what we're saying is, here's our original uranium. We're going to fling out a helium. And we're going to be left with some new nuclide. Well, we're losing the helium from this original nuclide. Well, that means we're losing 4 mass. 235 minus 4 is 231. We started with 92 protons, but we're losing 2. So now we're down to 90 protons. If we look on the periodic table, number 90 on the periodic table is, what we got? Thorium, TH. And just like we saw before, when we said they have to be the same, the total number of mass on the left, same as the total mass on the right. The number of protons on the left, same as the number of protons on the right. This helium, though, gets shot off into space. This is getting radiated out into space. It's getting shot off as radiation. And here is then the daughter nuclide that's left over. This is now what's left of the atom we started with. If we wanted, that thorium could break down again. It could break down some more. It could give off, sure, a beta particle, 0, -1. So now it's like we've got a second step. We've got a second reaction occurring here where we've going to break down again. Remember, to make a beta particle, a neutron turns into a proton. So our mass stays the same. We're still going to be at 231 on the mass, but we've gained a proton. Mathematically, that'd be 90 minus a -1. Well, that's 91. We've gained a proton. Look on the periodic table at number 91. That's protactinium. Our new nuclide is Pa. That could then go on to decay again if it wanted to, Eventually, this beta particle gets shot out into space. Here's our new daughter nuclide that remains. So armed with this, it's gonna kind of be a puzzle. We're going to be using this idea of decay series to start to work on our handout 3.3. Let me try kind of that first one under number 2, just to give you an example here. So number 2, letter A, I don't have it pulled up. It's going to be easier just for me to kind of show it here. We got 210 BI. It's breaking down, giving off a beta, and it's going to make something new. Our goal is to figure out what that new thing is going to be. Well, start by filling out in your atomic numbers. Find BI on the periodic table. It's number 83. Beta particle, we know, has an atomic number of -1. That's because we're gaining a proton when we form a beta particle. 210 minus 0 is 210 on our new particle. 83 minus a -1 is 84. We've made a new proton, so we gain a proton on that nuclear symbol. And number 84 on the periodic table is polonium. So here is what we would fill in the missing space under 2A. Armed with this, please try to complete handout or worksheet 3.3. Coming back next time I see you, we'll be taking a look at these, making sure we're doing okay, and we'll keep on talking about our nuclear changes.